Burning coal creates electricity. If you write that on your physics paper, you score 0 marks instantly. You've just fallen into the examiner's ultimate chess trap. Welcome to Physics 0625, Beating the Power Station Trap. We are skipping the fluff and immediately tackling the exact phrasing Cambridge examiners demand so you can protect your grade boundary. Let's get right into it.
So why exactly does the answer burning coal creates electricity score absolutely 0 marks? I mean, it sounds perfectly logical, doesn't it? You burn the fuel, you get the power. But if you write that directly on your exam paper, you are severely risking your grade. To see exactly why they penalize this so heavily, we need to hack the mechanics of the mark scheme.
Section 1. The examiner's chess trap.
Examiners set this specific trap because they aren't just testing if you know the start and end of a process. That would be too easy. They are testing your ability to sequence the exact, distinct steps of energy transfer using very precise scientific vocabulary. If we look at a standard coal-fired power station, the fatal mistake students make is completely ignoring all the massive, critical intermediary components between the raw fuel coming in on one side and the transmission lines leaving on the other. The thermal energy produced when fossil fuels are burned doesn't just magically teleport into being electricity. It has to pass through highly specific machinery. To secure top marks, you literally cannot afford to skip these middle steps.
Section 2. Power station components explained. Let's break these down.
Component 1 is the boiler. This is the absolute crucial first step. It's a device where thermal energy from burning those fossil fuels, or from nuclear fission, is transferred to water to turn it into high-pressure steam. So the golden rule to remember here is that the fuel doesn't make electricity, the fuel makes thermal energy, which then makes steam.
Next up is Component 2, the turbine. Now, examiners want you to specifically state that the blades of this turbine are forced to turn by that steam we just generated in the boiler. This step is all about transferring thermal energy strictly into kinetic energy. It's a physical movement step that bridges the gap in the process.
And finally, the turbine's axle turns component 3, the generator. What's really interesting here is the precise definition at play. Inside this generator, a voltage is induced in conducting wires when they physically move through a magnetic field. This is the exact dictionary definition of electromagnetic induction. If you miss this specific terminology, you drop the mark for sure.
But what happens if we aren't actually burning anything? If a question hits you with renewable resources that don't use a fuel, like wind or tidal power, remember that they bypass the boiler entirely. There is 0 thermal energy transfer required. Instead, moving air or moving water is used to turn the turbine directly, which then spins the generator. The sequence is definitely shorter, but listen closely. Mentioning the turbine and generator is still absolutely essential.
Section 3. The winning answer framework.
I am now going to give you the exact structural framework to ensure your written answers pull maximum marks every single time, no matter what energy resource the paper throws at you. Whenever you explain an energy resource, force your answer through this precise 4-step progression. First, state the core concept. Second, provide evidence or data from the scenario. Third, apply scientific reasoning to connect the two. And fourth, this is a real mark magnet. Lock it in with precise examiner wording. In just a moment, I'll show you the exact examiner clue that changes an evaluation answer completely. But first, you need the framework that makes that clue totally obvious.
Section 4. Spot the physics error. Let's see this in action. This perfectly illustrates the difference between an average grade and a top-tier grade. Look at the flawed answer. Tidal power is bad because building it destroys animal habitats. Notice how dangerously vague that is. Bad and destroys animal habitats are not physics terms. Now look at the improved top band answer. By flooding estuaries, a tidal barrage destroys wetlands, an important habitat for migrating birds. Wow. See the difference? It uses specific examiner wording straight from the coursebook. It mentions flooding estuaries, building a barrage, and destroying wetlands for migrating birds. That is how you use evidence and specific wording to absolutely guarantee the mark.
Here is the ultimate mark magnet for evaluation questions. This table summarizes exactly what Cambridge is looking for when comparing tidal and geothermal resources. For tidal energy, the key advantage isn't just that it's renewable, it's that tides are incredibly predictable, making it a highly reliable resource. But the disadvantage is the barrage blocking shipping routes and flooding estuaries. Conversely, geothermal energy, which uses hot underground rocks, usually near volcanoes, has basically no obvious disadvantages. But it's severely limited by geography. There are just very few places on Earth where it is actually available to use.
All right, here is an interactive checkpoint straight from the source questions. Take a second, pause, and predict the answer. In what way is a hydroelectric power station just like a cell or a battery? How does a massive wall of water behind a dam relate to a tiny battery in a circuit?
Got your answer? The examiner-style feedback here is that both systems act as a reliable store of energy. A battery holds chemical potential energy, right? While a hydroelectric dam holds an enormous amount of gravitational potential energy in the reservoir water. They both hold a massive potential store of energy that can be deployed into a circuit completely on demand.
Section 5. Your next strategic move.
Okay, so we have successfully generated the electricity, correctly defined the boiler, turbine, and generator, and bypassed the examiner's zero-mark trap. We are doing great. But this introduces an enormous, unresolved problem in the physics timeline. Once the electricity leaves the generator, it has to travel through transmission lines over massive distances to get to our homes and schools. The fatal issue here is that without some major intervention, the electricity will lose almost all of its energy as heat to the surroundings before it ever reaches its destination. Which leaves us with the ultimate high-mark question. How do we manipulate induced EMF to survive the national grid? Seriously, how do we use transformers to step up voltage and step down current to prevent massive power loss across these huge distances? If you don't know the exact mechanism for this, the examiner's next trap will absolutely catch you. We have to ensure it doesn't burn away before reaching our cities. If generating the power is half the battle, ensuring it doesn't waste away as heat is the true engineering marvel. To find the critical checkmate move for transformers and grab the top band evaluation framework, you must click on the next explainer on your screen right now. And make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. I'll see you in the next one.